So in this video, we're going to see how to use a new tool for solving quadratic equations called the quadratic formula. Some of you may have watched the video introducing it, showing where it came from. And then at the end of this, because it is our last lesson on solving quadratics, we're going to summarize methods of solving quadratic equations because we have three and we want to talk about when do you use what. So first example, we're going to solve this and it asks us to use the quadratic formula. We could certainly look at it and think that inverse operations are going to be a challenge because we got the x squared and the x. You might be thinking about factored equals 0 or the zero product principle, but if you analyze that, you'd find out that 2x squared minus x minus 2 doesn't factor. So we need another tool, and that's where the quadratic formula came in. So luckily, some people did some hard work, which you might have seen a video on earlier, and they figured out that the solution to this equation, and any quadratic equation, there's two of them, and we can use this formula that involves the coefficient of x squared, the coefficient of x, and the constant when it's in this form, and we will evaluate x that way. So in this particular problem, a is 2, and the number in front of x is b, and I don't see that in our equation, but I hope we're used to seeing knowing that when you see an x and there's no coefficient in front, it's a 1. So b is 1, positive 1 for that matter. And then c is the constant at the end, and in this case, it's negative 2. So these are the three values you need to use this formula. And this formula, again, just the way it works is if you have an equation that looks like this and you want to solve for x and you can't factor it, you can find the value of x by plugging the coefficients into this equation. Now I have my coefficients laid out. So notice, because I see this mistake a lot from students who are learning it the first time, they're dying to put x in here, but x isn't going into a, b, or c. X is being solved for. If you want to know where x is in this work we're doing, it's over here. And we are using just the numbers, the coefficients a, b, and c to figure out what x was. So with that in mind, we'll fill in an a where we see an a b where we see a b, a c where we see a c, and we will simplify the best we can. So we'll start over here. Negative, the numerator is the opposite of b. That's our first term, and that's 1. And then b shows up again underneath the square root symbol. So we are up to this point now. We substituted 1 for b. The next variable in our equation is a, and that shows up twice. That shows up here and here, and that means we need to substitute a 2 in for each of those a's to solve this particular equation. Okay, good. And the last variable we see is c, and c shows up once in our formula, and c, careful here, is a negative 2. So when we substitute, we have to make sure we have a negative 2 in there. So this then is our answer, and we have to always follow the order of operations. And I hope that over the course of the year, you've kind of really gotten used to separating things out based on addition and subtraction. So I see a term here, which is pretty simplified. I see underneath the square root symbol, there's some simplifying we have to do, which is 2 terms. It'll be 1, it looks like plus some number here because of the minus times a minus, a negative. And then my denominator is also its own term. So those 3 things are going to get our attention right now. And with the negative 1 being as simple as it is, and the 2 times 2 being as simple, I really encourage students to kind of go off to the side and figure out what b squared minus 4ac, the stuff underneath the square root symbol, what that is separately. So it's this, and again, now you can really see clearly there's 2 terms there. First term is just going to be 1. The second term is going to be negative 4 times 2 times negative 2, which is 16. So the value underneath the square root symbol is 17. And I do like to do that off to the side for 2 reasons. One is it's just kind of visually easier, and then 2, you'll see at the very end of this video. But that then turns into this, and that's our final answer. And now that's the kind of answer that, again, only a mathematician could love that. Because what is that? Is that a whole number? Is it a fraction? Is it negative? Is it positive? Like, what is that? Well, the square root of 17 is a little bit over 4. Because 16 is square root of 1, that's 4. And so this number represents 2 numbers. It represents negative 1 plus 4 point something divided by 4. And then it also represents negative 1 minus 4 point something divided by 4. And probably what we should be doing is we should be taking that to our calculator and being aware that there's 2 answers there. And that if you typed each of them into your calculator, you would find out that one of the numbers it represents is about 0.78, and the other one is about negative 1.28. So this may have really left the realm of, things make sense. We've done videos where we try to show why there's 2 answers to these things and stuff like that. And this may have really started to feel like it's getting away from that when you see an expression like that. But the fact of the matter is, these numbers here, these values for x that we just found, they might actually make some sense when you think back to our graph. What you've got here is you've got a graph of the expression 2x squared plus x minus 2. And we're wondering, when is that equal to 0? When is that expression spitting out a 0? And I can see some places where, like, if x was negative 2, it spits out 4. So negative 2 shouldn't be one of our solutions because that's not resulting in 0 as our expression. And here, this looks like when x is negative 1, -1 comes out. So -1 as an x shouldn't be our solution because it doesn't have an output that's 0. But it looks like right in between the -2 and the -1, there was certainly a place where 0 came out, and that was -1.28. And similarly, it shouldn't surprise us that 0.78 being one of our answers, that we see a place here where 0 appears to be coming out. So those two intercepts you'll learn, especially if you really start using technology to solve equations, are going to represent solutions to quadratics also. Okay, so it usually takes more than one example to get used to a formula. The big picture here is the formula will help you solve an equation if it's a quadratic and it's in this form and you can't factor it. So be aware, sometimes those equations come at you in different forms, like this guy. The left-hand side, we haven't seen that kind of multiplication in a while. Hopefully you still, you could always fall back on FOIL, but hopefully you remember that with that kind of symmetry, it was just sometimes a difference. You might come up with just 2 terms because of so much canceling in the outer and the inner. Starting to look a lot like a quadratic now. So the probably would ever get 0 on one side. With an x squared and an x, the zero product principle is a candidate until we look closely at this and figure out it doesn't factor. And once we figure out that doesn't factor, then the quadratic formula is the way to go. So once again, we'll take these guys and take a look and figure out what A is, what B is, and what C is. We'll throw them into this formula and we'll have our 2 answers for x. So it looks like A is 1 in this case, B is -3, and C is -5. And we'll use those accordingly. -3, including its sign, goes in everywhere the B is. And there's a couple places to be careful here, because when you have the opposite of -3, it's important that you realize both of those are in play, and this term becomes a +3. And when you have a -3 squared, especially if you're taking it to your calculator, it's easy to come up with -9. It's not. Any number squared besides 0 is a positive. So it looks like 3 is our term out there. 9 is what we get when we square -3. And a -4 times a 1 times a -5. Keep in mind, you might want to do that b squared minus 4ac off to the side. You might want to have gotten the 29 off to the side, but that's where we are. And 29 is not a very square rootable number. It's going to turn into a nasty decimal like we saw on the last page. So sometimes people just circle that and be done with it. And then sometimes people take it to your calculator to find out what those numbers really are. Depends on your context. If you're trying to answer a math question in a high-level math class, you could leave it like this because your whole audience will understand it. And if you're trying to actually build something and you figure out this is a measurement or something like that, probably an estimate is good enough. So that's our last example. All I want to do now is I just want to try to summarize for you where we've been in the last few weeks. So the first method we learned for solving quadratics was inverse operations, but it's a real specific setup. If you can get an equation to where you have something squared equals a number, taking the square root of both sides is going to get you there. This is not there yet, but we could imagine some steps we could take to get x minus 3 squared on one side, a number on the other side, and then you could square root both sides and be on your way. We saw that a few videos ago. More recently, we've been talking about the zero product principle, and that's when you can get a factored expression on one side and 0 on the other. And then the idea was you set each of these little expressions equal to 0 and solve 2 linears instead. This may not look like one just yet, but trust me, that factors. And then finally, we learned the quadratic formula, just in this video for the first time. We saw it used. And that's when you don't have something that can be factored, and you don't have something where inverse operations will be easy. We're going to take advantage of the work that other mathematicians have done for us, and we're going to use their formula, and we're just going to plug in A, B, and C from our equation. Now, one last note. You look at these two things and you think, boy, they look a lot alike. How am I supposed to know whether I factor or whether I use the quadratic formula? Because this is a lot of work to guess and check, only to find out that it doesn't factor, and now you got to do a lot of work to do the quadratic. Or this is a lot of work to begin with, and it's even more work when it would have factored because you've got just steps upon steps upon steps of simplification at the end. So what is the difference between those two? And it comes back to that observation that we introduced. That product, that outer product of those two coefficients, if you can find factor pairs of -90 that add to +43, it is worth your time to factor. And we found them. Over here, though, this product of -40, if you can find the factor pairs of -40 that add to -5, again, it's worth your time to try to factor it, but you can't. That's in our entire list. None of them add to -5. That's where we'd use the quadratic formula. So I know that was pretty quick, but I think this is a nice video to kind of bookmark and reference as you go, and you'll have a chance to practice some of that now.